So prior to the installation, we will have done a proper site survey. We will have checked line of sight and range, identify the mounting location and the power source, made sure we had all of our cabling with us, and collected all of our tools and safety equipment, and we're ready to begin. We want to start by removing the mount plate from the bottom of the transceiver. And this is done by first removing the shoulder bolt at the base. We're going to use a 6mm L-handled hex wrench to get that started, and then take the rest out just by hand. This is just really a safety bolt. Once the shoulder bolt's out, we can loosen up the azimuth bolt to the left side here in the picture, and then by pulling the transceiver upward, we're left with that mounting plate. The mounting plate has a positioning device on the top that looks like a small hockey puck, and this will help guide the transceiver head back onto the mounting plate and the mounting arm. You can also see the hole patterns here, which can be used for a wide number of mountings. We're going to attach the mounting arm to a 4 to 4.5 inch outside diameter pole using a pair of U-bolts with a 3/4 inch nut on the end. Included in the outdoor mounting kit hardware are some backer bars that actually hold tighter onto that 4.5 inch tube. We're not using them here in the picture, but they are recommended. In this case, the mounting arm is coming out perpendicular to the target line. In some cases, though, we'll want to face that mounting arm at the target. In some cases, we'll have it attached directly to a wall where there really won't be an option. We have a wall, it comes out of that wall and may point at the target or may point away from the target. We're going to want to place the mounting plate on top of that mounting arm. There are a number of holes patterns that you could use to do that, either further away or closer to the pole itself, and that's the preferred way here if you can do it. We'll attach this with 4 6mm hex bolts. We'll want to get those as tight as we can using the L-handle 6mm wrench provided. Place the outdoor transceiver over the base plate and slip it into position on that azimuth rotation shaft. Replace the shoulder bolt. We're going to want to get that good and tight. And we'll loosely tighten the azimuth clamp bolt, but we're going to need to run the unit left and right, so we're not going to want to have that too tight just yet. Remove the cover plate on the back and let it drop down on the hinges. First thing we're going to do is attach the negative 48 volt DC leads to the right side. Prior to doing this, we're going to want to make sure the on-off switch is in the off position. We've placed these 3 wires into a piece of conduit that comes out of our outdoor power module, and we're securing them using a straight slot screwdriver. When we throw the circuit breakers in the outdoor power module, you'll see the polarity light that's here to the left and slightly below the junction box come on. And when that polarity light comes on green, we'll know that we've got the right wires in the right holes. If it comes on red, we'll know that we've gotten the polarity crossed and we'll need to rewire the power coming into the bottom of the unit. There is a wiring diagram in the outdoor power module that goes into further detail. Next, we're going to want to attach the transceiver management fibers and the data fibers through conduit, through the base of the unit, and into the SC or Sam Charlie connectors that you see on the left side. In this example, we're using an elbow connector on that conduit. Just as an example, you may have to use that depending on the geometry of the transceiver head and the mounting arm. After cleaning the fibers, we're ready to attach them. SC connectors are keyed, so on the male side there's a tab that fits into the slot on the female side. Management goes on top, data below. If this were a Sonnet unit, OC3 or STM1, the data cables would be single mode fiber. In the case of the fast Ethernet, the data cabling is multi-mode fiber. Then come the temporary connections, the field service laptop, which is a straight through Cat5 with an RJ45 connector, and the USB cable, the B end, placed on the transceiver. The other ends of these, of course, will go into our field service laptop. In the outdoor power module, we'll power up the AC and the DC circuit breakers. After applying power at the outdoor power module, we'll look at that polarity light. If it comes on green, we're ready to power up the unit. If it comes on red, it means we've mixed up the polarity on the wires. We'll want to then power down the outdoor power module and swap those wires and power it back up and look for the green polarity light. Powering up the on-off switch, we'll see the blue LED go through a test pattern, and then finally it should come on solid blue. If it doesn't, if it continues to flash, or if it doesn't come on for some reason, we're going to need to do some troubleshooting, make sure we have correct power there and the like. And if it continues to flash blue, you should consult the field installation and service manual for troubleshooting steps that apply. The first step in the alignment process is the course alignment. And on the base of the unit, you'll see a rifle sight, a V notch on the back and a tab on the front. You want to place the target line directly beneath those two. By loosening the azimuth and the elevation bolts, we should have some latitude to swing the transceiver left and right, up and down, to put the target on that side. In this particular case, we're shooting for a pattern of windows on the far side. We can't see the transceiver on the far side yet, so we're going to shoot for the middle window in the pattern. We make the same connections on our field service laptop, the USB and the Cat5 cable. We'll want to change the IP address, the gateway, and the net mask. I can do this a number of different ways. One way is to identify the network icon on the desktop, give it a right mouse click, select Properties, and then under Network and Dial-Up Connections, look for Local Area Connection, give that a right mouse click, again select Properties, and then select Internet Protocol TCP/IP, hit Properties one more time, and then select Use the following IP address, and we'll put one in just for test here. We'll put in a subnet mask and a default gateway, and hit OK. OK again. Now we'll launch the Terabeam transceiver installer software. There's an icon for that on the desktop if I've installed it properly. I'll double click that. And we'll find one device under the Discovered Devices tab. We identify it by its MAC address. It also shows its default IP address here. The first thing I'm going to want to do is change the IP address and some of the other network settings. So I'm going to click once on the device to highlight it, and then I'm going to give it a host name. I'll just call it test. I'll give it an IP address. A gateway, and a subnet mask, which I'll keep the same. Then I'll click Modify Network Configuration. This is uploading those parameters from the laptop into the transceiver head. Now I can connect to the unit. I'm going to click the Connect button, and looking down in the lower left-hand corner of the TTI screen, you can see the connected indicator, and it's green. Now on our installation, I need to look at the camera view. On the toolbar at the top, you see a number of icons, and on the far left side, you see one that looks like a camera. So I'll click that once. The first time you do this, it takes several minutes for the camera to boot up while it installs various drivers and so forth. Finally, I get a shot of my camera and crosshairs. And as you can see here, I'm a little bit up and left of the window. I'm going to aim for the center, slightly left of center on this bank of windows. Now the first thing I need to do is tell the transceiver what range we're at here. There's a little bit of a parallax between the camera aperture and the receiver aperture, and I correct for that by typing in the correct number of meters. I figured it's about 620 meters. I type in 620, I go over to the right transceiver button and click that, and then I'm ready to use the fine alignment screws, the fine adjustment screws, to, in this case, bring the camera to the right side in azimuth, and then I'm going to go to the elevation screw towards the bottom of the unit and crank that until I bring the crosshairs right over the window where the unit is. If I have too far to go, with the fine alignment screws, if I haven't done as stellar a job in the coarse alignment, I may choose to loosen up the azimuth and alignment screws on the outer side, on the outer part of the transceiver, until I get close enough to use the fine alignment screws. Those fine alignment screws have a total turn limit of 9 turns on them, and since I can't see inside the unit, I can't see with the way the springs are compressed, I'm going to have to go by feel. If I go and use the fine alignment screws and start to hit some resistance to basically I'm coming to the stop, and I'm still not where I want to be with the crosshairs, what I want to do then is back off those screws halfway, or in other words 4.5 turns back in either azimuth or in elevation, and then go back with a coarse alignment, looking at my camera, getting as close as I can to the target, tighten those down, go back to the fine alignment screws, and bring it in the final way from there. In order to kick off the spiral scan, we need to go into the FSO performance screen in the Terabeam transceiver installer software. So the second icon from the left is the FSO performance monitor screen. We'll click that. And if we look towards the right side of the display, we see two buttons, Start Fast Spiral Scan and Start Slow Spiral Scan. Neither one of these is active yet because it's still in a tracking state. So we're going to have to turn the tracking button into the off position. Why do we have a fast and a slow speed? The idea would be that on one side of the link we would make that a fast spiral scan, and the other side we would make a slow spiral scan, and in this way we would guarantee, hopefully, that the two sides will find each other. Potentially, if they were both traveling the same speed, they might never catch up to each other, and I always equate that to a dog chasing its tail. It never quite gets there. So we've turned the tracking button off. This enables both fast and slow. I'm going to hit the fast spiral scan here, and on the opposite side I would go over and hit the slow spiral scan. As I click the fast spiral scan button, notice the tracking state towards the bottom of the numerical window in the upper right hand corner. The tracking state says FSPRL, and that stands for fast spiral. On the other side it would say SSPRL for slow spiral. Now the spiral is confirmed on the left hand side of the display by the white dot. This is actually a visual impression of the way the mirror is scanning, and you're going to see it scan from a very narrow dot in the middle and an increasingly wider and wider circular pattern. As it's spinning around there, you can also see the tracking angle X and tracking angle Y numbers moving to, again, reflect the position of the mirror at any given time. The minute that this transceiver detects power from the other side, the tracking state changed from FSPRL, fast spiral, to FTRAK, or fast track. When you see fast track, you know that this side has detected the other side, and vice versa. You'll also confirm this by looking up to where it says receive power, minimum, average, and maximum. Notice this one has shot all the way up to 568 microwatts of energy. So we're getting power on the detector, and the mirror has basically stopped moving. It's moving a little bit now, but it's not in its spiral scan anymore. Finally, if we wait long enough, and it takes just a few seconds, the tracking state will automatically change from fast track or slow track into track mirror. And here you see it, TKMIR. That's the operational tracking state of the unit. So what we're going to attempt to do here is, by turning the fine alignment screws, we're going to want to zero out the mirror. That means we want this mirror perfectly centered in its field of view so that it has maximum range left and right and up and down. And so I'm going to take those fine alignment screws, turn them in both elevation and azimuth, and as I twist them, I will watch that white dot go up into the center of the crosshairs. And of course, while I'm doing that, I'm making sure that the tracking state says track mirror. So it's actively, the mirror is actively staying locked onto the far side. Okay, and this is going to give us maximum play of that mirror, the full 7 milliradians to the right and left. When we're done with the alignment, we're going to want to tighten down the azimuth and the elevation screws. There are 2 elevation screws on the left side and another 2 on the right, with a single azimuth elevation screw coming straight out the back. Even though we don't show a torque wrench here, you'll want to use a torque wrench and follow the specification found in the field installation and service manual to apply the correct number of foot-pounds. After our installation is done, we can remove the cabling for our field service laptop and secure the access cover.